Dear students, today we'll start with our next topic, that is a dynamic microphone, which can also be called as moving coil microphone, which is a part of your audio systems in applications of electronic engineering. So the heading will be dynamic microphone, which can also be called as moving coil microphone. So let's see the basic things of it. Now to look, the microphone will be looking like this, and in this microphone you can put your audio signals. You can incident your audio signals from this side. So here you can see the picture of a dynamic microphone in which you can give your audio signals from this side, and those audio signals will enter and they will be converted into electrical energy, and the output here will come out as electrical energy, and that output will be further transferred through wire or wireless. So here you can get electrical energy. Okay, so this can be further going with wire or wireless media. Okay, so this is a picture in which we have shown a example, one type of dynamic microphone. Now, if you go to see the exact principle, what happens in a dynamic microphone, then we can show with this diagram. Now, in this diagram, you can see that the first part is shown as diaphragm. Diaphragm is the part where our input explanation will start. So here you can see the diaphragm. Now diaphragm is this part, whatever we are having. This is called as diaphragm. Okay, now your sound waves, which you want to convert into electrical waves, will be incident here, will be striking here. Sound waves will be striking here. Okay. Now, as the sound waves strike, this diaphragm will vibrate. This will vibrate. Okay. Now, this diaphragm is connected to coil. This is the coil. This is all your coil. Okay. And this coil is placed in a magnetic field. In a magnetic field. So here you can have your north pole, south pole. Okay, north pole, south pole. So this is all magnetic lines of force. Even here you can have magnetic lines of force. And this coil is being placed in the magnetic field of permanent magnet. So this is your permanent magnet here. This is what you're showing is a permanent magnet. Now, when the diaphragm vibrates, when this diaphragm vibrates because of sound input, okay, that vibration will make this coil to move in and out. So this coil also will have a movement in and out. So this, say this is a coil, and if it is going to move in a permanent magnetic field, this is your permanent magnetic field. Okay, and when this coil is going to move, there will be a current produced in it. Current are produced in it, and that current will flow. Okay, now that current you have to tap and take through wires. That you have to tap and take through wires. Now the current variation, whatever you get, will be corresponding to the variation of the sound waves input what you gave to the diaphragm. That means sound energy is converted into electrical energy in the form of current. Okay. Now this is the basic principle on which the moving coil or dynamic microphone works. Okay. Now here you can see one more diagram. In this also same thing we have shown. Here are your sound waves which will come. This will be the sound waves, and this is your moving coil. So this is full is coil. This is the permanent magnet. So the coil is placed in the magnetic field of the permanent magnet. So when the sound waves hit the diaphragm, okay, so this is your diaphragm. This line, whatever is shown, is your diaphragm. Now, when the sound waves hit the diaphragm here, the diaphragm will vibrate, That vibration, that mechanical movement is transferred to the moving coil. The moving coil also moves in and out in the magnetic field. Depending on the movement of the moving coil in a magnetic field, a current is induced in it. Now, that current we have to tap and take as output current signal, and that signal will be nothing but your representation of the sound waves. Okay, so as a whole, you're going to convert your sound waves into electrical energy. So this a type of a principal used microphone is called as dynamic microphone, or it is also called as moving coil microphone. So if you see the theory how moving coil dynamic phones work, so when wire is moved within a magnetic field, a current is generated in the wire. Using this induction principle, the dynamic microphone uses a wire coil, magnet, and a thin diaphragm to capture the audio signal. The diaphragm is attached to the coil. When the diaphragm vibrates in response to incoming sound waves, the coil moves backwards and forwards past the magnet. This creates an electrical current in the coil. This is important. The movement of the coil in the permanent magnetic field will induce a current in the coil, which is channeled from the microphone along the wires. Okay. Now, what are the advantages of dynamic microphone? So, first advantage is it is rugged and able to handle high sound pressure levels like those delivered by a kick drum. Second is it provides good sound quality in all areas of microphone performance. Third is they do not require a power source to run. And fourth is they are relatively cheap. So these are some of the main advantages of your dynamic microphone. Disadvantages are number one, heavy microphone diaphragm and wire coil limits the movement of the assembly, which in turn restricts the frequency and transient response of the microphone. And second, our disadvantages are generally it is not as suitable as a condenser microphones for recording instruments with higher frequencies and harmonics, such as a violin. So, summary if you see about a dynamic microphone, then you can say that a dynamic microphone can be used for many applications. It will produce an excellent sound and are suitably rugged, great for traveling on the road. They are best avoided when recording high frequency content on an important recording. For a reliable everyday tasks, you will not find a more of multifaceted, trustworthy device than a good quality dynamic microphone. Okay. So this is what was the summary of a dynamic microphone. Thank you, students.